Ladies and gentlemen, boys and girls, welcome to another episode of Transparent Physics. This is another in our Just Data series. And in this exploration, we're going to be taking a look at sound waves in a resonance tube. Lots of cool things you can do with this data, not the least of which is measure the speed of sound itself. So without further ado, let's get started. And we can see the resonance tube apparatus. It's pretty simple overall. The star of the show is that large vertical cylinder. It's made of plastic. Sometimes it's made of glass. And at the bottom of it, you can see a hose coming out of it. And that hose is connected to a cup. And that's how we raise and lower the water in the tube. Actually, the water is really not what we're concerned about. It's the air column above the water that determines where the resonance occurs. You can also see that I put a little food coloring in the water. That just makes it easier to see during the video. We've got our assortment of tuning forks here, a mallet to hit the tuning forks with, our obligatory cup of tea, and then we can see the mounting up here is where we put our tuning fork. The tuning fork vibrates above the column, and from the top of the tube downward is where the resonance occurs. In a tube that's open at the top, we're going to have an antinode at the top, and then we're going to have a node wherever the water level is at the bottom. And we can adjust that water level by taking the cup and raising it higher or lower. And as we raise it higher or lower, you can see the water level is going up. And as the water level goes up, that means the height of the column is decreasing. Or the height of the air column is decreasing, I should say. And one important thing to note is the numbering on the tube is set up so that the height at the top is a 0, which indicates a measurement from the top down, which shows you the depth of the air column. So for example, down here, the air column is about 21 or 20 centimeters. It keeps on moving on me. All right, around 18-ish centimeters or so down. So that's 18 centimeters from the top. So that would be the depth of the air column. So it's a pretty simple setup, all things considered, but it's a very effective way to measure resonance in a tube that is open on one end. And remember, wherever that water level is going to be an obligatory node. At the top is going to be an obligatory antinode. And then in between, that's where the magic happens.
No tuning forks were harmed in the making of this video. If you enjoyed hearing how those resonance effects occurred inside the tube, consider liking the video. If you have any questions about the data or the analysis, leave it in the comment field below. And to see what's coming next from Transparent Physics and to help the channel grow, please consider clicking the subscribe button. As always, thanks for watching and listening to this lesson on the properties of sound. I hope I've made things a little clearer for you on this lesson of Transparent Physics.